Hello everyone, this lecture video is all about the significant figures. First, let's define this one. So, significant figures pertain to the digits or figures that are certain to give reasonably reliable information. And these significant figures are helpful in attaining a level of certainty when expressing calculated quantity. So, let us proceed on the rules and determining significant figures. We have here first, all non-zero digits are significant. So, when we say non-zero digits, these are numbers 1 to 9. First example, we have here 746 milliliters. So we have here 3 significant figures. That is 1, 2, 3. And then next example, 2,463,882 seconds. We have here 7 significant figures. On this example, 3, 6, 7. And then 23.16, that is 4 significant figures. Then we have here 3, 4, 5, 123.44. We have there 5 significant figures. Next rule, we have here zeros to the left of the first non-zero digit are not significant. So we call the zeros to the left of the first non-zero digit as leading zeros. So the leading zeros are not to be included in calculating the number of significant figures. First example, we have 0.32. We have here 2 significant figures. And here we have 0.006385. We have here 4 significant figures. And then from here, 0.000003, we have here 1 significant figure. And then next rule, zeros between non-zero digits are significant. So we call the zeros between non-zero digits as captive zeros. So we include the number of captive zeros in calculating the number of significant figures. So for first example, we have here 3054. We have here 4 significant figures. And then 5.03, we have here 3 significant figures. And then 5.23000007, we have here 10 significant figures. Let me count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. Am I correct? 2, 4, 6, 8, 10. Yes. And then next rule, we have here zeros to the right of a non-zero digit with a decimal point are significant. So we call the zeros to the right of a non-zero digit to the right as trailing zeros. So meaning to say, we will include the trailing zeros with a decimal point in calculating the amount of significant numbers or figures. So for first example, we have here 4 significant figures. For second example, we have 3 significant figures. We will include that since it has a decimal point. And then for the last example, we have here 3, 4, 5. 5 significant figures here. And the next rule is zeros at the end of a non-zero digit without a decimal point are not significant. So if there's a decimal point, we will include the trailing zeros. But if the trailing zeros doesn't have a decimal point, we won't count that as a significant one. So for first example, we have here 400 kilometers. We only have here 1 significant figure. And then for the next example, we only have here 3 significant figure for 12,500, that is 3. And then for the last example, we have here 7,630. So this is as well 3 significant figures. Since we do not have the decimal point for the trailing zeros, we won't include the zeros here. And then let us proceed on significant figures in calculations. So how do we determine the significant figures in calculations? There are rules that we must consider. For example, for addition and subtraction. So the rule here is that the number of decimal places in the answer should be the same as the number with the least decimal places among those being added or subtracted. So for example, I have here 2.051 millimeter and then plus 3.56 millimeter plus 72.1 millimeter. So meaning to say, in addition and subtraction, in determining the number of decimal places, we have to calculate or base that on the least decimal places. So how many decimal places do we have here in 2.051 millimeter? We have here 3. And then for 3.56 millimeter, we have 2 decimal places. And then 72.1 millimeter, we have here 1 decimal place. So if you will add this one, that will be 77.711 millimeter. But then the final answer should only have 1 decimal place since that is the least number of decimal place among the addends. So therefore, the final answer for this one is 77.7 millimeter. This is the final answer. You will base on the least decimal place among the addends. Now for subtraction, okay, we have here 32.63. We have 2 decimal places, this one. And 5.2, we have 1 decimal place. So if you will subtract, you will have 27.43. But then the final answer should only contain 1 decimal place since the subtrahend here only have 1 decimal place, or that is the least value of the decimal place. So the answer should be here 27.4. This is the final answer, the least decimal place. So the rule for multiplication and division, we have here the answer should have the same number of significant figures as the number among those being multiplied or divided with the least number of significant figures. So, if in addition and subtraction, you have to consider the least decimal places in the final answer. But here in multiplication division, the least number of significant figure must prevail. I have here 7.065 meter multiplied to 12.0 meter. The number of significant figure here is 4 for 7.065, 4 significant figures. And then 12.0, we have here 3 significant figures. If you will multiply 7.065 to 12.0, that will be 84.78. So 84.78, we have here 4 significant figures, right? But then the least here among the numbers being multiplied is the 3 significant figures. So your final answer should be in 3 significant figures, but because that is the least number of significant figures in the values being multiplied. So 84.78 should have a final answer of 84.8. You have to round off if it is greater than 5, the next number. If it is lesser, then retain the number next to it or before it. So this is 84.8. This is the final answer for that. Next, for division, the same rules apply in multiplication and division. You should consider the least significant figure. So I have here 162.05 divided by 3.2. So 162.05 has 5 significant figures and 3.2 have a 2 significant figures. So dividing that, you will have 50.640.625 meters per second, and then the final answer should be only in 2 significant figures because that is the least number of significant figures that is being divided in this. So this is the least one. So the final answer instead of all of this should be 51. You have to round off the next number to it into this one because it is greater than 5. So it is 51 instead of this.